we increasingly let AI grade AI. One language model writes out its step-by-step reasoning, and another model acts as the judge, deciding whether that reasoning is good. But here's the uncomfortable question. When an AI judge approves a chain of reasoning, is it really checking that the logic holds, or is it just nodding along because the answer looks plausible? This paper, C2 Faith, builds a benchmark to test exactly that. It asks whether LLM judges can assess process faithfulness, the quality of the reasoning itself, rather than just answer plausibility. And the answer is sobering. Today's best judges have real, systematic blind spots. First, a key distinction. A reasoning chain can reach the correct final answer while the steps in between are broken, skipping crucial logic, or just rationalizing an answer it reached some other way. Faithfulness is about the process, not the answer. And this matters because we use AI judges to filter and train other models. Unfaithful reasoning that slips past a judge gets baked right into the next generation of AI. The paper's central move is to split faithfulness into two clean, measurable dimensions. Causality asks, does each step logically follow from the steps before it? And coverage asks, are the essential intermediate inferences actually present, or did the chain skip the hard part? A chain can fail on either axis independently. Here's a preview of what they found across 3 frontier judges. No single model wins at everything. Judges can usually tell that an error exists, but struggle to point to exactly where it is. And on coverage, every judge is far too generous, giving high marks even when most of the reasoning has been deleted. Let's understand how they proved all this. Now the heart of the paper, the methodology. The genius here is control. To test a judge reliably, you need reasoning chains where you already know the exact answer, where the error is, and what's missing. So they manufacture those chains deliberately. Let's build it up step by step. They start from PRM800K, a dataset of math solutions where every single step was hand-labeled by humans as correct, neutral, or wrong. From this, they keep only what they call perfect chains, solutions of at least 5 steps where every step is human-verified correct. That gives 450 pristine chains to work with, a clean foundation with no pre-existing errors. One clever guardrail before we touch anything. They only perturb the middle region of each chain, roughly the 30 to 90% zone. Why? If you only ever broke the first or last step, a judge could cheat by always checking the edges. Forcing errors into the middle means the judge has to genuinely read the whole reasoning. Now the first kind of flaw, a causality perturbation. They pick one middle step and replace it within a causal variant, a rewrite that looks mathematically plausible but quietly breaks the logic. An LLM does this rewrite, flipping a comparator, swapping a quantity, or sneaking in an unwarranted assumption. Crucially, only that one step changes, and they record exactly which index they broke. The second kind of flaw, a coverage perturbation. Instead of breaking a step, they delete steps. They remove a controlled fraction of the middle steps at 4 levels, 10, 30, 50, and even 70% gone. The remaining steps stay in order. Now they have chains that are missing known amounts of reasoning, perfect for testing whether a judge notices the gaps. With these 2 datasets built, they define 3 tasks of increasing difficulty. Task 1, binary detection. Shown a step, does it follow, yes or no? Task 2, localization. Shown the whole broken chain, point to the exact step that's wrong. And Task 3, coverage scoring. Rate how complete a chain is on a 0 to 4 scale. Detect, locate, and judge completeness. Test 3 frontier judges: GPT 4.1, DeepSeek v3.1, and O4mini. And here's a measurement subtlety that turns out to be everything. It's not enough to ask how often a judge catches a planted error. You also have to rerun it on the original, unbroken chains and count how often it falsely cries wolf. That false positive rate is what separates a real detector from a trigger-happy one. That's the whole machine. Perfect chains, 1 planted logical flaw or a known set of deletions, and 3 escalating tasks scored against ground truth. Now, how did the judges actually do? The results are full of surprises. Task 1, binary detection. On raw numbers, DeepSeek looks like the champion, catching 94. 7% of planted errors versus 82. 7 for GPT 4.1. But remember the false alarm check. DeepSeek also flags nearly 30% of perfectly correct steps as broken, 3 times the others. Once you subtract false alarms, DeepSeek drops to last, and O4mini quietly takes the lead. Now the most striking result, When you move from task 1 to task 2, the rankings flip. The model that was best at saying yes, an error exists, is not the best at finding where it is. O4 Mini jumps from middle of the pack to clearly best at localization. Being good at detection tells you almost nothing about being good at attribution. And underneath that flip is the paper's signature finding, the detection localization gap. Across every model, judges detect that something is wrong far more often than they can pinpoint exactly what. Gap is huge, 26 to 33 percentage points. They smell smoke but can't find the fire. There's even a consistent direction to their mistakes. Every judge has an early prediction bias. It tends to blame a step that comes before the real one. Likely reason is intuitive. The judge flags the first thing that looks suspicious and stops scanning, instead of finding the actual injected break further down. Now task 3, coverage, and this is the most worrying result of all. Every judge is far too generous. Even when 70% of the middle reasoning has been deleted, average scores stay around 3 out of 4. Judges treat surface coherence as proof of completeness. If what's left still reads smoothly, they assume nothing important is missing. DeepSeek shows the starkest version of this. At low deletion, it hands out the maximum score over 95% of the time, a ceiling collapse, so its ratings have essentially zero correlation with the truth. The paper's read is that it scores on global coherence, not local completeness. Partially deleted chains still look coherent, so they still get top marks. So what makes an error catchable? They dug in, and the strongest predictor is math symbol density. Steps packed with symbols, equations, comparators, operators, give the judge concrete anchors to verify against. Errors hidden in plain natural language reasoning, where the judge has to make a softer plausibility call, slip through far more often. But there's a genuinely hopeful finding too. Judges fail on different examples, their mistakes are complementary. A case that fools GPT 4.1 often doesn't fool O4 Mini. The paper estimates that simply combining all 3 judges could push detection above 98%. The weakness of any one judge is partly covered by the others. Let's pull it together. C2 Faith is the first benchmark to cleanly separate causality and coverage, with controlled, known flaws on both axes. And it exposes real limits in today's AI judges. They confuse detection with localization, they mistake coherence for completeness, and their raw scores can be misleading until you account for false alarms. And why care? Because these judges aren't just grading homework. They filter training data and shape reward signals for the next generation of models. If a judge systematically overcredits incomplete or subtly broken reasoning, that unfaithfulness gets reinforced and amplified. Reliable process evaluation isn't a nicety, it's a safety prerequisite. The authors are careful about scope. The benchmark lives in competition-style math, so other domains are untested. The coverage ground truth is itself LLM-generated, and they use a single fixed prompt per task, so claims that a judge can't do something are sensitive to prompting. Honest limitations, and a clear roadmap for what comes next. So here's the one-line takeaway. When an AI judges another AI's reasoning, it can usually tell that something is off, but it often can't say what, and it badly overestimates how complete the reasoning is. C2 Faith gives us a controlled way to measure those blind spots, the first step toward judges we can actually trust. Thanks for watching.